Hello everyone and welcome to the Future of Space. I'm your host, Daniel Fox. Our guest today is Scott Hubbard. Scott is a physicist, the Adjunct Professor of Aeronautics and Astronautics at Stanford University, former Director of NASA's Ames Research Center, and NASA's first Mars Program Director. He is the Director Emeritus of the Stanford Center of Excellence for Commercial Space Transportation and chairs the SpaceX Commercial Crew Safety Advisory Panel. Hubbard is also a musician and award-winning author. His book, Exploring Mars, Chronicles from a Decade of Discovery, tells of his years at NASA restructuring the Mars program. Scott, welcome to the Future Space.
Glad to be here, Daniel. Look forward to our talk.
Yes, I have to say it was wonderful spending time with you and Catherine and your wife at Starmus. If there's one thing that these things do is really create these opportunities for great conversation. So it was fun.
Yes, indeed it was. I didn't get to know Simon Phillips until then, the drummer for Toto for 20 years, but now he asks me questions about Apollo 11, and I ask him questions about AI and music. So it really is a fabulous opportunity.
Excellent. You will be there again next year, I assume?
As far as I know.
Excellent.
We'll see where it goes.
Scott, before we get into your career and space, what's going on, what happened today, or wherever the conversation takes us, I would like to start with, could you share with us 3 words that, for you, captures the essence of space?
Vast, dangerous, and awe-inspiring.
Is life in general could be described the same way? Vast, dangerous, married life also?
and sometimes awe-inspiring. Yes. I don't know if it's vast in the same way that the universe is. It's extremely difficult for, I think, almost anybody. Maybe it wasn't for Stephen Hawking, but to grasp the idea of infinity, of nothingness that suddenly burst, a little wiggle in the vacuum, and all of a sudden here was an expanding universe. But those concepts, I think, are difficult for the human mind to grasp.
And I think it's going to get even more complicated. I was listening yesterday about a talk on quantum physics and trying to wrap my head on everything that was being said, or if anything made sense. And it just seems like every door that we open will lead to more complicated doors. Questions that we're not even thinking about of asking 5 years ago. Now when the place, it's not even that we can ask the questions, that we didn't even think of these questions, and now we can ask these questions. Do you feel like that?
Oh yeah, definitely. What physics has been trying to do for 100 years is to rationalize Einstein's general relativity, which covers the physics of the very large, of the immense, with quantum mechanics, which is the physics of the extremely small. And thus far, nobody, they joke about, do you have guts? The grand unified theory of everything. And they've not gotten there yet. String theory has evolved to the point where people are wondering if it's even testable. It's got so many complications. So I think that if you layer on issues of what is consciousness, for example, do you really not have a reality unless you observe it? I mean, that's what the double slit experiment tells us. But bridging those things is going to lead us, I think, in entirely new directions that we don't even contemplate yet. Did
you ever think? I mean, I was looking at your website and your journey. 9 years old. You musician and space at the same time. Did you ever think, since 9 years old, that you would be here with today's tools and opportunities to discover what we can discover?
Only in science fiction. I read science and science fiction almost simultaneously from that age, and I dreamed about knowing whether there was life elsewhere in the universe. And as I've said several times, I'll die happy if we find microbes on Mars or pond scum on Europa. The getting there, though, was really quite a journey, and we'll talk about that in a bit. But I didn't think ahead to where we have astrobiology, where we're really understanding the DNA and RNA universe, and the ability now to examine both the very, very small at the quantum level and also with Hubble and now James Webb to look backwards in time to just after the Big Bang.
It's hard to wrap your mind on that, right? To see the remnants of light of 13, 14 billion years. I mean, just to try to capture what really the means, or the vastness of the universe is incredible. Scott, you've astrophysicists or physicists, a career in NASA in the space for 45 years plus. You obviously understand the science story of space, the technology story of going to space. But what would be for you the human story of space?
I think it's partly what's over the next hill. Now, that doesn't appeal to everybody. Some people are fine saying, I'll stay right here in the cave. I got a fire. We killed a mastodon yesterday. There's plenty to eat. You go out and see what's over the next hill. I'll stay right here. But I think there is a feature of the human condition that requires that, some fraction of us really are driven to know what's over the next hill, what's on the next planet, what's at the edge of the universe. So I truly think that's a motivating factor, in addition to all the questions I asked when I was 9 years old about, is there life elsewhere in the universe?
So, was that the question when you were 9 years old? If there is life in the universe? While all the other 9 years old were trying to figure out how to get candy for the store around the corner, you were like, I wonder up there.
Yeah, well, there was a very popular at the time, a couple of books. There was Isaac Asimov, who wrote both science and science fiction. The Foundation trilogy is famous in science fiction circles. There's a guy named George Gamow who wrote 1, 2, 3 Infinity, and then an astronomer named Fred Hoyle. And particularly in Hoyle's book, he said what was known at the time, and again, this was the late 50s, about the origins of the universe and the possible origin of life. And they were just beginning to understand how some of the basic molecules could then, over time, maybe combine to make more complex molecules and then organic material. When I was reading this, it was not that long after the famous Urey Miller experiment where they put a bunch of what we would call now prebiotic gases and ran a lightning bolt, an electric arc through it, and found amino acids. So it was just at the very beginning, and I personally found that fascinating. I was still bought comic books, right? But which my mother threw out, I did ponder that. I did wonder about it when I was even a little boy.
Do you think that we, not even that we're, if we're good, but do you think that we can imagine the future? Because I tried to look into, often I use the example of when I flew over New York and at night in New York City, Manhattan, I'm looking out the window and I'm looking at the skyscrapers with the lights, and I'm really taking a moment to realize that I'm on this machine, flying machine, right, where I can eat, sleep, I can go to the bathroom, and I'm using this device that can take a photograph and call someone halfway across the globe and do banking. Like if I went back 300 years of when the Italian explorer landed on the shores of what New York was back then, it was just a forest. Like even if I would ask him or tell him what the future is, he would think I'm a sorcery witch and throw me to the dungeons. Like not even capable of putting those dots together. And most likely there's a future ahead of us that seems so foreign and we can't imagine. Do you think that we actually can look into the future, or we will always be missing kind of 3/4 of the picture?
I think that human beings are pretty good at the, let's call it the gradual extrapolation, or taking something that exists today and imagining that it's 1,000 times more powerful, or runs 1,000,000 times faster and so forth. What I think that we don't particularly do a good job of is understanding and anticipating things that are a step function, or where you go from having no idea that relativity works or that quantum mechanics works to where it's something now where you have devices in your iPhone that depend on quantum mechanics to function. I mean, there are years and years ago, somebody invented something called the tunneling diode. Well, that says it is based on the premise that a particle can be here or it can be there, and it's probabilistic. And so I think that we, science fiction has tried to imagine first contact with a civilization that's far older, but it could be that that is such a leap that it creates cognitive dissonance, that you wouldn't maybe even recognize, because our senses would be overloaded if you were to come into contact with an alien technology or an alien civilization that's 2 million years ahead of us. So what we know is there will be other great leaps of understanding. Where the 19th century physicists got it all wrong was when they were writing statements, including some very famous people saying everything that needs to be known is known, and all we got to do is add a few more digits to the accuracy, go from 0.99 to 0.9999, and completely missed what would then become some very, at the time, very odd pieces of observation that turned out to completely throw all of their understanding out the window. And we're going to have others like that.
Oh, I mean, most likely. I was watching it yesterday, something about quantum mechanics, and when they explained some about negative energy, and where the movie Tenet with Chris Nolan was actually not like everything about the movie has a connection to something that in theory could be explained. And I was trying to wrap my head around the negative, right? The positive, the negative, how so I cannot imagine where we're going to be going from here. I guess you must be excited almost every day, or of trying to find out or asking new questions, correct?
Oh yeah, that's the thing about science. It's a real jobs program. I because for everything you discover, it just raises more questions. And that's a good thing. It's as it should be. If we ever got to the point where we thought we knew it all, then we're probably making a huge mistake. Because every day there is something. I mean, look, poor Boeing, finally, 4 years after SpaceX, they finally launched human beings into space. And they were supposed to be, with their 100-year history, they were supposed to be the leaders. And instead, the upstart company beat them with humans by, as I said, 4 years.
Now, about Starliner, this episode will come out in a couple of weeks, but just for the record, Starliner did launch finally this morning after a third attempt. Do you think that we have to be careful that the success of the launch cannot be mistaken for the failure of the program, that the NASA and Boeing and the SLS, the way that things have been done before, has to migrate to NASA just being a leader of idea and funding the commercial institute, but get out of the race in the same way that now he has outsourced the Mars, right? The getting to Mars. Do you think that that's the future of NASA?
Yeah, I never thought when I was director of Ames, when I was inside NASA, that the agency should be in the trucking business. It's not what a futuristic, forward-leaning agency of high technology is all about. And so I always encourage these entrepreneurs. It took a while to find the right combination of entrepreneurial spirit, sensible engineering approaches, and enough money. I mean, the entry bar to the rocket business is very, very high. You can't do it on the cheap. It's not like sitting in your garage writing code. I mean, this is a lot of money. But it finally happened. And I think that NASA realized pretty soon, as they were putting out the original calls for ideas, that this was a way in which the agency could transition to doing what they do best. I mean, being at the pointy end of the spear, going places like Mars Sample Return or Europa Clipper, where there's no business case, at least not yet. And let the business case of development of first near-Earth space and then out to maybe lunar space, let the companies that are really good at that take it over. And it seems to be working. I think the cost of access to space has come down and will come down even further.
You redesigned the Mars program at NASA. You were at Ames, at the Ames Research Center. I sometimes feel that Mars is, if we go back into the days of ocean exploration, the big ticket that all nations, European nations, were looking for was the route to India, for the spices, and ultimately that just became kind of the excuse for a lot of other things. I sometimes question that Mars is that vision of the future, but is that apple, that attraction that actually will lead to things that are much more realistic, whether it's, a moon by another planet, that actually makes more sense to settle over there. But the Mars itself will become kind of maybe just a station, but not a big development. What are your thoughts on that?
Well, I always approached Mars, both when I was the first Mars program director and had the job to fix the mess, as they told me, and distinguished the science of that, which is very sound. It's been reviewed and verified over and over and over again that for the reason that you can get there with current rockets every 2 years, that it has, by all appearances, from everything we've now gathered, was once warm and wet on the surface, had energy, had clearly organic materials, that it is the best place to look for the fingerprints of life outside of our own planet. We can come back to Europa in a minute, but I always approached this as a science goal. That was, for me, the driving interest in Mars. Other people, Elon Musk among them, see this as a future civilization, a million-person city on Mars, second home for humanity, that sort of thing. I've always thought, in terms of the human exploration of Mars, that it is a research outpost, not unlike what we have in Antarctica. And using that as a base from which to learn about the past, present, and maybe future of the rest of the planet makes the most sense to me. The moon as a permanent base is equally difficult because there's no atmosphere. You've got to mine everything and convert it from, if there is that much ice in the craters of the South Pole, then you still got to mine it and process it. So establishing a new home for civilization is a tall order. But as we said at the very beginning, exploration and then possibly settlement, that's been something human beings have done for, we've been in this form for about 2 million years, as hominids of one sort or another. We seem to always do that, so I don't discount it at all, but when I was the first Mars program director, the job one was the science.
Was NASA always part of the career path, or was that more of the path of a fly going in many places and then whoops, kind of find your way to NASA?
It was, I guess, conceptually part of the potential future that I had, but actually becoming part of the agency, becoming an employee of the agency, didn't occur until later. I was following several different paths. There came a point early in my career when I just finished my undergraduate degree in physics and astronomy as a double major. But I was at Vanderbilt University in Nashville, Tennessee, Music City, USA. And I had been playing guitar since I was 13 or 14, and I was at a point where I was thinking, rocket science or music? Rocket science or music? And I ended up choosing rocket science, and came to the West Coast and got a position at Lawrence Berkeley National Laboratory, and went into a sort of a second phase looking into solid state semiconductor physics, which was a very hot topic right then. I'm talking the early 1970s. But along the way, I worked on some space experiments, including actually building an experiment with my own two hands that went up on Apollo Soyuz. That's how long ago it was. And I caught the space bug all over again, so that eventually led me to be an employee of NASA.
And how did you come or get to the place where you saw the involvement of the commercial as an asset for NASA, right? When you were at Ames with Google and, with SpaceX, onward, because NASA obviously did not have a culture of seeking out or even welcoming, these type of partnership. So is that because you were hanging out, you were as everybody was going for the gum, the candy at the store, you were looking in the opposite direction, hanging out with the Silicon Valley. How did these dots connect?
Yeah, the closest connection, I guess, was being in San Francisco and then in Silicon Valley and inhabiting that ecosystem. I mean, it really is a pretty unique place. Many other areas have tried to duplicate it, and with various degrees of success. But seeing all the people taking risk to do something innovative, I skipped over the part of my career that was between Lawrence Berkeley and NASA Ames. And that's when, as a result of my work in semiconductor physics, I had an opportunity to be an entrepreneur. And a group of us put together a company that was devoted to creating ultra high purity material for radiation detection and measurement. This was the point where nuclear power was going to be, that was the future, was to go from coal, fossil fuels, and nuclear power. Of course, it got derailed for a bunch of both political and technical reasons. But part of the company that I helped found was building one of the key elements of that, which was the radiation detectors and monitors that you would need. And so I learned how to do research, development, production, and sales all at the same time. I sort of jumped off into the deep end of the pool, like a lot of entrepreneurs. But we made a go of it for about 5 years. The company was bought. They moved many of the parts to the home office in Connecticut, and I decided to stay in the San Francisco Bay Area. And that's when I learned of a position at NASA Ames and joined up with them in 1987. So I had had a taste of being an entrepreneur, and my role in joining Ames was to help create new business. So I, without knowing it, kind of became they call it the BD guy, the business development only in science and exploration missions. And that led me to have a great appreciation for what can be done if you have the right technology and engineering, if you have the right personality. You got to be willing to take risk, and the funding or the backing, of course, to make it happen. So when I was at Ames, I was approached by a guy who's long forgotten. His name is Benson, and he founded a company called Space Dev. And Space Dev created a space plane called the Dream Chaser, which was then bought by another company. And long story short is NASA is actually using that. And what Benson wanted was he wanted to have some validation of his design. And a lot of the people around the center were old-time aeronautics guys. They were fascinated by the problem. I mean, Ames is a technology and research center first. It does flight projects, but not like JPL or Goddard. And they said, well, this is kind of interesting. So net was that I ended up arranging to almost donate some effort and some time and even some wind tunnel test to this entrepreneur. And that got me more involved in trying to help these people. I created something called the Space Portal, where entrepreneurs could come and learn how NASA works, how the space program works. And that ultimately led to a lot of the other things that I've done over the years. And one example of the old NASA and the new NASA, in my days as director, we were always seeking to figure out how to use the property that we owned. Because when the Navy left in 1995, the center ended up inheriting about 1,200 acres of prime real estate in Silicon Valley. And so I was the guy who signed the first deal with Google for 1 million square feet of R&D space and joint projects. And so when I informed NASA headquarters, they said, "You did what?" Like, come again? And Google was not the behemoth then that it is now, although it was known. Nowadays, NASA's going out of their way to try to encourage entrepreneurship and to see how much of their space station program, launch capabilities, and so forth they can offload to the private sector, because they can do that stuff better.
In at Starmus, Charlie Duke was there talking about the moon, and there's a slide that shows the schedule of launches, and you have these two SLS departure, and then you have a SpaceX, and then after that it goes back to SLS. And then I told Charlie that I have a feeling that once it goes to SpaceX, it will not go back to SLS just because of the economics of it. What are your thoughts on the projected schedule of how Artemis is going to unfold itself?
When you go to the next level of technology and engineering, there are and economics, there's quite a few factors at play. So let me talk about a few of those. One is that I was, for a few years, on the NASA Advisory Council. This is the highest level advisory entity to the administrator of NASA. And we were looking at an early version of the SLS. And the presenter said, well, we expect to launch this at least once a year. And we all looked at each other, the panel did, the council did, and said, what? You can't maintain proficiency without at least 2 launches a year. Now, if you can do multiple launches a year, and if you can, through the economies of scale, bring the price down, then you can start to make more of a business case for retaining the SLS. But it was designed and built in, I'll call it the old way, as to say, NASA specifying nearly every nut and bolt. That tends to drive up the cost. Second thing with Starship is they're going to have another test. They hope to bring the whole vehicle back. And what I learned in the years that I chaired the SpaceX commercial crew panel was that their build a little, test a little philosophy is very advantageous. So I can see the Starship over time becoming more successful. The big issue is in the number of on-orbit refuelings and the transfer at scale of large amounts of liquid, of cryogen, mainly liquid oxygen. And if they can demonstrate those things, then I think they have a chance to become the dominant transport. And then there's Blue Origin, which NASA's also selected. So if you're sitting in a very senior position at NASA headquarters, what you want is some competition right now. You want SpaceX and Blue Origin to sharpen their pencils and come up with the best engineering, most cost-effective solution, and you want to have something in your back pocket in case those fail. And right now that's the SLS. From a decision maker's point of view, if Blue and SpaceX can both demonstrate consistent performance, then I think you may see the SLS, pushed over to the sidelines. But right now, NASA, I think, has trouble doing that because they just don't know if these two companies are going to deliver. SpaceX has delivered brilliantly to the space station. Now you're talking about another leap of capability.
Now, every time that you hear these projections, I mean, either from Elon Musk or other companies saying, oh, we're going to be doing this in 2 years, 3 years, that narrative has always been easy to throw out there in Silicon Valley, whether in the software industry or whether you're doing things that whether you hit the mark or miss the mark does not have real big impact, right? But these objectives of being on the moon or going to Mars has a lot more to it and a lot more unforeseen challenges that people anticipate. We just heard that Dear Moon, the Japanese billionaire, and the Dear Moon project has been canceled, just simply because he doesn't know when it would be possible, right? So in the back of your mind, do you have a number of years, a timeline to say, it's most likely it's going to be in 50 years we're going to have significant presence on the moon, and more like 75 years Mars, or something like that?
I don't have as explicit a timeline, partly because we haven't talked about the international scene and the possible influence of a number of Chinese successes might have on the U.S. Congress. We're getting to the point with both Artemis and other science missions, like Mars sample return, for example, where the limiting factor is more the budget than the technology. So it's possible. I don't know if there's a Sputnik moment in there. If the Chinese did put humans on the moon or return samples from Mars much earlier than the U.S. is planning, that might have a stimulation to the policymakers and the budgeteers. If you just do incremental, business as usual, then you have to apply the Silicon Valley discount to these projections, because they can always go into beta test, and if they ship 1,000 units and some of them fail, so what? The stakes are much higher, as you pointed out, and you can't get what an old timer once taught me, that you can't get launch fever. You can't decide you've got to launch just because. Well, a cheap failure does nobody any good, and so this is a very difficult business. But I do think that we will see an Artemis 2 launch around the moon within the next 2 years, and a landing within a couple of years after that. I would really like to see the Mars sample return progress. If they come up with an architecture that's affordable, or that the budgeteers put the money in so that we get those samples back. We've spent the better part of the last 10, 20 years preparing to get these very well selected samples. And I really want to get those back before the headlines are grabbed by, literally a grab sample that the Chinese do for performance, not necessarily for science.
China just landed for recently on the towards the South Pole, and already their samples have left and on the way back. China has definitely been taking the lead. Do you think that the U.S. now is understanding how behind they are, or that Sputnik moment has not arrived, has not really caught on with the U.S. administration?
Yeah, it's a little more complex than that. The administrator in his budget testimony has mentioned the Chinese capabilities. I wouldn't characterize the Chinese as being ahead. I mean, if you look at the huge range of stuff that NASA science does, I mean, it's got something like 70 operating missions. I mean, some very large number. The way in which I have observed the Chinese operating is in the sense of demonstrating something and not the follow-up or of making it part of a program. It's almost a performative stunt. Not quite, but you know, they did land, the only other country to ever land a rover on Mars, but then it stopped working for unknown reasons after a month or so. Well, Spirit lasted 7 years, Opportunity lasted 14 years, result of a whole bunch of factors. So before I would agree that they're ahead, I think I would like to see them have a little more of a track record. Nevertheless, I think one of the reasons they have been able to do this is because they have, by all accounts, somewhat lower budget than NASA, but very consistent. They don't have to go through all the political shenanigans that NASA does of continuing resolutions and shut the government down and all this politically motivated stuff. For years, people in the agency wanted to have a 2-year budget at least, you know, where you appropriate it for 2 years, not just one. Something like that would probably help. But I do think if you get past the fog of the next election, that some of these accomplishments may start to sink in. And if there's evidence that China really will bring back samples, even if they're not well selected, makes a great headline, by 2033 or so, that could be a Sputnik moment, or add to the realization that they're really pushing ahead.
Now, Scott, I want to be mindful of your time. There are a couple of questions that I want to ask you. I want to make sure that we put a little bit of spotlight on your book. As a musician, on top of that, we write music that connects us to emotions or help us process certain things. Books, we write them for different reasons. When you left NASA, did you write the book because you felt that the public needed to know that, or because it was more of a cathartic process for you to go over your years at NASA? Why did you write the book about Mars and your years over there?
It was very interesting. It was actually neither of the two cases you mentioned. It was because one of my dear friends who worked with me, he was part of my kitchen cabinet, he was part of the group I would turn to for thoughts and advice and experience, is a systems engineer and author named Gentry Lee. If you look at the number of the books written by the late Sir Arthur C. Clarke, you will see in the second and third Rama series, Arthur C. Clarke and Gentry Lee. And when we got the program reconstructed, when I finally sold it to everybody, Office of Management and Budget and the appropriations and everybody, and it was underway, and I then later on returned back to Ames to become the director eventually, Gentry kept bugging me. He said, "This program is for the next 10 years. Turned out to be 20 years. This never happens. This never happens. You get to sell one program, one mission at a time. You sold you created, developed, and sold an entire decade program, which is now almost 20 years. You've got to write this down. You must write down all the obstacles and the personalities and how you did it, because this is lessons for the future. People need to think in terms of programs for the future, and you've got to write it down." So Gentry kept pestering me, and I finally said, okay, all right, and started writing drafts, and got his advice as well as another friend of mine, Neil deGrasse Tyson, about how to approach the publishers, and got a lot of good advice, and it ended up in the book. And it's got in there not only stories, but some of how I created this program out of a series of disasters. And so I hope that others can learn from that.
How you brought your entrepreneur spirit to the institution and the hustling mentality. Well, we'll make sure that the links for the book for the Amazon and where they can purchase it is in the information in the comments. Scott, through the career and as a musician and as a human human person, what would be Scott's 3 words of wisdom?
Take thoughtful risk.
Love it.
Don't take foolish risk. Don't do anything dumb. But, manage and mitigate it, but take thoughtful risk.
It's finding a fine balance. I recently wrote about also the balance with realism and optimism, right? You cannot be naive and thinking everything is going to be fine, or like, oh, I'm invincible. You have to understand the risk and the challenges that are, that are ahead of you or that you're facing, but also understanding the agency that you have in dealing with them. And that's often, I think, one of the issue that we have. We've become too risk averse. We're behind our walls or computers, even in human relationship, even more so since COVID. Life is challenging by nature. Transformation is challenging by nature. Innovation and mistakes are two of the same until you have an innovation, right? It's only the hindsight that gives you the capacity to say, well, that was stupid or that worked, but the road to it was the same. But even with climate change, like, these moments are always hard, but what we have is the agency to do something about it and to learn, and that process cannot be skipped. The solutions cannot magically appear without that hardship in the process. So I love that. Scott, it was a pleasure. Thank you so very much for coming on the Future of Space. I'm really happy that we get to spend some time in Starmus, and I'm looking forward for our next time together. I'll let you know when either at Stanford in your neck of the wood, or when their paths cross again.
Daniel, thank you so much. I really enjoyed talking to you today. And the future of space is bright. Let's help make it so.
Absolutely. Thank you.
Thank you.